Hello students, this is Harish Konda. Welcome to my channel, the Chemistry Classroom. So today we are going to discuss about the language of chemistry. What is language of chemistry? How we are going to learn? Now we discuss. Generally, for the chemistry, we need the basics. The basics are discussed in language of chemistry. So generally, you know very well, in the universe, everything is the matter. The matter is classified into two. The one is called pure substance and second is called mixture. So the pure substance again it is classified into two. The one is called element and the second is called compound. So when we are dividing the element into the particles, we are getting one undividable particle. That particle is called molecule. The molecule is the fundamental particle for the matter. Why? Because when the molecules are added, what you get? The element you get. When the elements are added, what you get? The compound you get. The compounds are added, what you get? The mixture you get. The mixture is the matter. So again, the molecules are divided. Why? Because the science is developed. The molecule can be divided. The molecule can be divided into the atoms. So atoms are the combination. So when your atoms are combined, what you form? The molecule you form. So the molecules when they are combined, the element you form. The elements when they are combined, what you form? The compound you form. With the compound you combined mixture. Mixture is the matter. So now we discuss about the atoms. Atoms, for the atom, what is the atom? What we have the particles in the atom? What is the structure of the atom? We discuss later. Why? Because it's a separate topic that is called atomic structure. Now we are not discussing about atomic structure. Why? Because we have to learn about the language of chemistry. So about the atom, how they are combined to form the molecule, how they are combined to form the element, how they are combined to form the compounds. Now we discuss. Why? Because the compounds, if you know about the compounds, how they are forming, what is the chemical properties of that compound, that means we are discussing about the matter. So to know about the compounds, what you have to know? You know about the elements. The elements are the combination of atoms. So how they are combining, how the compounds are formed, now we discuss in language of chemistry. Understood? There the compounds, how they are forming, now we are going to discuss. So we are not discussing about the atom, that atomic structure, what are the particles that we have in the atom, we are not discussing. Just we discuss in the atom we have the three particles. The one is called electrons and protons and neutrons. So in this, the electrons and protons are always equal in the atom. Why? Because the atom is having zero charge, it is not having any charge. That means the protons and electrons are equal in the atom. Why? Because the protons are positively charged and the electrons are negatively charged. When they are two equal, the electrons and protons are equal, automatically you are getting the zero charge. That means in general, in the elements, so we have the atoms, it is a combination of atoms. The atoms are zero charge, that means neutrally charged. Why? Because the protons and electrons are equal. All atoms are not stable. To get the stability, they have to get the inert gas configuration. In general, we have some inert gases, that is very stable elements, that is helium, neon, argon, krypton, xenon and radon. These elements are called inert gases. Actually, they are noble gases. They are very stable one. They are not compound. They are not forming the compounds. Why? Because they are already getting the stable. So these elements are very stable. The remaining elements want to get the stability as inert gases. So for that, sometimes they lose the electrons, sometimes they gain the electrons. To get the stability, they are losing the electrons, they are gaining the electrons. So when the atoms are losing the electrons, when one atom is approached, which is required electron, When the atom is gaining the electron, when one atom is approached, it is losing the electron. So the atoms, when they are getting approached, one atom is losing the electron and one atom is gaining the electron. Automatically, mutually they are bonded. That means what they are formed, the compound they are formed. So how many electrons they are lost, how many bonds they are formed, that we discuss in language of chemistry. Okay, in language of chemistry, how many bonds it is forming, how many compounds it is forming, that we discuss here. So now we discuss one by one. So what are the topics we see here? So in general, that helium and neon, argon, krypton, xenon and radon, they are the inert gases. To get stability, some elements are losing the electron, some elements are gaining the electron. Here one example will take the sodium. I am taking the example. The sodium atomic number is 11. So the sodium is having 11 protons and 11 electrons. In the nucleus we have 11 protons. In the around the nucleus we have 11 electrons. Already we told the atom is having zero charge. That means the protons and electrons are equal. So how the protons are getting positive? So we have 11 protons. That means 11 positive charges. The electrons are negative. So how many electrons we have? 11 electrons. So 11 negative. So 11 plus 11 minus. That atom is having zero charge. Here you observe the sodium atomic number is 11. It is very near to neon and argon atoms. So the neon and argon are the inert gases. The neon is atomic number 10 and argon atomic number is 18. That means the sodium is in between neon and argon. So why? Because to get stability, it has to get the neon configuration. At the same time, it has to get the argon configuration. If the sodium is getting neon configuration, it is stable. At the same time, the sodium is getting argon configuration, it is stable. So what configuration is going to get? Now we see. The atomic number of sodium is 11. It is having 11 protons and 11 electrons. So the neon atomic number is 10. So here 10 protons and 10 electrons we have. To get stability, what it has to do? The sodium has to lose one electron. When one electron is lost, so what happened here? 11 electrons are converted into 10 electrons. That means the neon configuration is getting. The sodium is getting neon configuration. That means it is getting stable. Or the sodium wants to get argon configuration. What we have to do? We have to gain 7 electrons. Why? Because here we have 18 protons and 18 electrons. Already we have 11 electrons. When the 7 electrons are gained, it is getting 18 electrons. That also the inert gas configuration. The sodium, if it wants to get stability, sometimes it is losing 1 electron. It has to gain 7 electrons to get argon configuration, which is very easy. To lose 1 electron is very easy. That means the sodium is losing 1 electron. So similarly, one more element I am taking, the chlorine. The chlorine atomic number is 17. So you have 17 protons and 17 electrons. The 17 protons and 17 electrons, so the chlorine is getting zero charge, neutrally charged. The chlorine is in between neon and argon. The neon is 10, argon is 18. So the chlorine is in between neon and argon. If it gets neon configuration, it is stable. If it is getting argon configuration, it is stable. To get neon configuration, it has to lose 7 electrons. To get argon configuration, it has to gain only 1 electron. So the chlorine is in between neon and argon. If it wants to get neon configuration, it has to lose 7 electrons. To get to argon configuration, it has to gain only 1 electron, which is very easy. To get 1 electron is very easy. The chlorine is getting 1 electron. So here you see the sodium is losing 1 electron and the chlorine is getting 1 electron. Now we observe the sodium, it is never loses the electron. It always in the atom state, it not loses the electron. So when it approaches the chlorine, then only it loses the electrons. So here the sodium is approached by the chlorine. So the sodium is having the property to lose the electron. The chlorine is having the property to gain the electron. So what happened here? The sodium loses one electron. That electron is gained by the chlorine, and the sodium is getting stable. At the same time, the chlorine also getting the stable. So here the sodium, when it is approached to the chlorine, the sodium to get stability, it is losing one electron. At the same time, to get the stability, the chlorine is gaining one electron. The two atoms are getting stable. So when they are getting the stable, what happened now you see? Here, before the losing of electron, the sodium is having zero charge. But what happened here? One electron is lost by the sodium. When one electron is lost, here we have 11 protons as is, but the electron is lost. Now we have 10 electrons only. So 11 protons and 10 electrons, that means 11 positive charges and 10 negative charges. What we have? One positive charge is excess. So when the sodium is getting stable, the sodium is converted as Na plus ion. That means it is converted as cation. So when the chlorine is gaining one electron, before gaining the electron, the chlorine is having 17 protons and 17 electrons, it is zero charge. When one electron if it is gained, so what happened now see? So 17 protons and 17 electrons is zero charge. But when the electron is gained by the chlorine, so what happened? 17 protons as it is, but the electrons are 18. Now what happened? One negative charge is excess, so automatically the chlorine is getting one negative charge. When the sodium is losing one electron, the sodium is forming Na plus. The chlorine, when it is gaining one electron, the chlorine is forming Cl minus. So after getting the stability, the sodium plus is formed and chlorine minus is formed. That means two opposite charges, ions are formed. So automatically they have the attraction. Why? Because they are formed opposite charge. So the sodium plus is attracted with the chlorine minus. So what happened here? NaCl, one compound we form. Now understood? The sodium is losing one electron, so automatically it loses one electron and the chlorine gains one electron. So what happened here? NaCl, the compound you form. So one more example I am taking, you see here, the magnesium I am taking. The magnesium atomic number, it is 12. It is in between neon and argon. The neon is 10, argon is 18. To get neon configuration, it has to lose 2 electrons. So before losing, we have 12 protons and 12 electrons. But to get stability, what happened here? 2 electrons are lost. Now the protons are 12, so 12 plus, the electrons are 12, the 12 minus, it is getting zero charge. But after losing 2 electrons, what happened? The protons are same only, but the electrons are 10 only. Why? Because in the 12 electrons, 2 electrons are lost. So you have 10 electrons only, 12 protons, that means 12 plus, 10 electrons, that means 10 minus. What happened here? 2 positive charges are excess. So the magnesium is getting 2 positive charges, Mg plus plus or Mg plus 2. The both you can write Mg plus plus or Mg plus 2. So here, when the magnesium is losing the electron, when the chlorine is approached to the magnesium, why? Because the magnesium is having the losing property, the chlorine is having the gaining property. So the magnesium is approached by the chlorine, then magnesium to get stability, it is losing electrons. So when the electrons are lost, that is gained by chlorine. Here what happened now, see, to get stability, magnesium is losing 2 electrons, but here the chlorine we have only 1 electron is gained. Why? Because the chlorine capacity, it can gain only 1 electron to form Cl minus ion. Why? Because to get stability, it required only 1 electron. That electron is gained by the chlorine and Cl minus is formed. Here the magnesium is releasing 2 electrons. So here the chlorine is gained only 1 electron. What it means? 1 chlorine is not enough to gain the electrons. Why? Because here 2 electrons are released. So here how many chlorines are required here? 2 chlorines are required. The same one more chlorine I am taking. The chlorine, it is gaining only 1 electron and what it is forming? Cl minus it is forming. So when the magnesium losing 2 electrons, that 2 electrons gained by 2 chlorines. So what happened here? One magnesium giving for 2 chlorines. One magnesium is giving 2 electrons for 2 chlorines. MgCl is formed. So mathematically what you write? MgCl2 you write. Why? Because here we have 2 chlorines. So MgCl2 you are writing. So here the magnesium, to get stability, the 2 electrons are loose. To get stability, the chlorine is gaining only 1 electron. So for chlorine required only 1 electron, but magnesium is giving 2 electrons. So magnesium required 2 chlorines. The 2 chlorines are gained 2 electrons. So what you form? The MgCl2 you form. So one more example we take. For example, I am taking aluminium. The atomic number of aluminium is 13. So how many protons we have? 13 protons and 13 electrons. So 13 positive and 13 negative. So aluminium is getting 0 charge. To get stability, the aluminium is in between neon and argon. The neon is 10, argon is 18. To get neon configuration, aluminum has to lose 3 electrons. To get 3 electrons, the aluminum is losing 3 electrons to get stability. So what happened here? The 13 protons like that only, but the electrons 3 are loose, so we have only 10 electrons. Now what happened? 13 plus and 10 minus. So what happened? Here 3 positive charges are excess. So aluminum is getting plus 3 charge. Now you see, aluminum can lose 3 electrons. But when it is losing, when the chlorine is approached to the aluminium. So the chlorine is approached to the aluminum is releasing 3 electrons. To get stability, compulsory it has to lose 3 electrons. So when the 3 electrons are loose, but the 3 electrons are not accepted by the chlorine. Why? Because the chlorine is having the capacity only 1 electron. It can gain only 1 electron to form Cl minus Ar. To get argon configuration required only 1 electron. So 1 chlorine is not enough to get 3 electrons. So how many chlorines are required here? 3 chlorines are required. Each chlorine is gaining 1 electron. So here 3 chlorines are required. The 3 chlorines are gaining 3 electrons from 1 aluminium. So here what happened here, you see, the aluminium is giving 3 electrons for 3 chlorines. So what happened here? AlCl is formed. So mathematically what you write? AlCl3 you write. So here you see what happened here. The sodium is losing only 1 electron. With 1 chlorine it is formed. Here magnesium is losing 2 electrons. So 2 chlorines it is formed. Aluminum is releasing 3 electrons. So with 3 chlorines it is formed. Now you have one definition. So here how many electrons are loose? You understand? How many electrons are loose? That is equal to the bonding. Here sodium is losing only 1 electron. It can form the bond with chlorine only 1. So magnesium is losing 2 electrons. With 2 chlorines it is bonding. Aluminium losing 3 electrons. With 3 chlorines it is bonding. The sodium is bonding only 1. The magnesium bonding 2. The aluminium forming 3. So how many electrons are loose? That is equal to the bonding. So that bonds, the number of bonds is called valency. What it is called? Valency. So here the sodium valence is 1. The magnesium valence is 2 and the aluminium valence is 3. So here the valency what we are discussing, it is valency. The sodium valence is 1. Here the magnesium valence is 2. Here the aluminium valence is 3. What is valency? How many electrons are loose? That is equal to the bonding. That number of bonds is called valency. So the sodium valence is 1. The magnesium valence is 2 and the aluminium valence is 3. So now we take another example. So now you see. So another example will take the same sodium I am taking. The sodium atomic number is 11. So here 11 protons and 11 electrons. To get stability for neon, the sodium is losing only 1 electron. The Na plus is formed. The sodium, how many electrons it is losing? Only 1 electron it is losing. So with chlorine now we discussed, it is gaining only 1 electron to form Cl minus. So what do you form? NaCl you form. So I am taking one more example, that is oxygen. Right? So oxygen atomic number is 8. It is having 8 protons and 8 electrons. It is very near to helium and neon. The helium atomic number is 2, neon atomic number is 10. To get stability, oxygen can get the helium configuration, oxygen can get the neon configuration. The both are getting stable only. So here it has to lose 6 electrons, here it has to gain 2 electrons. So when the 2 electrons are gained, the oxygen is getting stability. So here oxygen atomic number 8 and 8 protons and 8 electrons. So the 8 protons means 8 plus and 8 minus, it is getting 0 charge. But the 2 electrons are gained by the oxygen. What happened? 8 protons are same only, but now the electrons are 10 electrons. Already we have 8 electrons. The 2 electrons are gained. Now we are getting 10 electrons. So 8 protons, so it means 8 plus. 10 electrons means 10 minus. So what happened? 2 negative charges are excess. So oxygen is getting minus 2 charge. Now you see, the oxygen is gaining the electron. When it is gained the electron, when it is approached with the sodium. The sodium is having the property that is losing property, and oxygen is having the property that is gaining property. When these two atoms are approached, the sodium approach the oxygen, sodium is losing 1 electron and getting stable. Oxygen is gaining 2 electrons and getting stable. But here you see, the sodium can release only 1 electron, but oxygen requires 2 electrons. When the 2 electrons are gained, then only oxygen is getting stable. But here when sodium is not enough to get the stability. Why? Because the sodium can give only 1 electron, but oxygen requires 2 electrons. So what happened here? The sodium, we need 2 sodiums to get stability. Why? Because the 2 sodiums are releasing 2 electrons. The 2 electrons are gained by the oxygen. Now the oxygen is getting stable. So that means to get stable, the 2 sodiums are required for 1 oxygen. The 2 sodiums are giving 2 electrons to the oxygen. The oxygen is getting stable. So actually what we have to write? NaO we have to write. But mathematically what you write? Na2O we write. The 2 sodiums are giving 2 electrons. The 2 electrons are gained by the oxygen. The oxygen is getting stable. Now we see one more example. The nitrogen I take. The nitrogen atomic number it is 7. It is having 7 protons and 7 electrons. That means 7 plus and 7 minus. It is getting 0. To get stability, it is in between helium and neon. Helium is 2, neon is 10. To get stability, nitrogen, what happened? 3 electrons are gained by the nitrogen. Why? Because it is very close to neon. To get stability, it is required 3 electrons. When 3 electrons are gained, nitrogen is getting stable. So, before gaining the electron, we have 7 protons and 7 electrons. It is neutrally charged. But after gaining the 3 electrons, the 17 protons size is same only, but the electrons are 10. So, 7 protons means 7 plus, 10 electrons means minus 10. So, what you have? 3 negative charges are excess. So, what you form? N minus 3 you are forming. Now, you see, the sodium, it is approached with the nitrogen. When the sodium is approached to the nitrogen, the sodium is having the property to lose the electrons. So nitrogen is having the property to gain the electrons. So here the sodium is releasing only 1 electron and nitrogen is required 3 electrons. So how many sodiums are required here? 3 sodiums are required. So what it means? The 3 sodiums are giving 3 electrons to 1 nitrogen. So, to get stability, it required 3 electrons. The 3 electrons are gained by 3 sodiums. So, mathematically, what you write? Na3N you write. Na3N you form. Now, you observe one thing. Here, the chlorine is gaining only 1 electron. With 1 sodium, it is bonded. Here, oxygen is gaining 2 electrons. With 2 sodiums, it is bonded. Nitrogen is gaining 3 electrons. With 3 sodiums, it is bonded. Here, the chlorine is gaining only 1 electron. With 1 sodium, it is bonded. The oxygen is gaining 2 electrons. With 2 sodiums, it is bonded. Nitrogen is getting 3 electrons. With 3 sodiums, it is bonded. Now, you see how many electrons are gained. That is equal to the bonding again. Here, the chlorine required only 1 electron. The 1 sodium only it is bonded. Here, the oxygen required 2 electrons. The 2 sodiums, it is bonded. Nitrogen required 3 electrons. With 3 sodiums it is bonded. How many electrons are gained or how many electrons are required? The gain, that is equal to the bonding again. That bonding is called valency. So here the chlorine valency. What is the valency of chlorine here? It is 1. What is the valency of oxygen is 2. What is the valency of nitrogen is 3. So now we have one more definition. So how many electrons are gained by the atom is equal to the bonding. That number of bonds is called valency. Here the chlorine is valency 1, oxygen valency is 2 and the nitrogen valency 3. So we have two definitions for the valency. How many electrons are lost? Or how many electrons are gained? That is equal to the bonding. That number of bonds is called valency. When you know the valency, you can write the formula. So that formula, for that formula, we have one principle. That principle is called criss-cross principle. Now we discuss criss-cross principle. So what is the principle? Now we see. So when you know the valencies of the atoms, so automatically you can write. But here the criss-cross principle have some limitations. What is the limitations? Now we see. In the criss-cross principle, we have two elements only. For the two elemented compounds are written by criss-cross principle. In one element is called A and another element is called B. That is the first condition. For two elemented, two atoms, when you have two atoms, the two elements, the two elements only form the formula with criss-cross principle. That is the first limitation. And the second limitation, the two elements A and B are having the opposite property. That is the second condition. Compulsory it has to opposite property. So if the A lose the electrons, the B gain the electrons. The A and B are the elements. They are having the opposite property. A is having losing property and B is having gaining property. They are the opposite elements. The A is losing the electrons and B is gaining the electron. When the A is losing the electron, so it is forming one valency. Why? Because already we discussed how many electrons are loosed. That is equal to the bonding. That number of bonds is called valency. So here the valency of A is called N. What is the valency? It is N. So N means number of electrons are loosed by the A. Similarly, B is gaining the electron. Already we given the definition. So how many electrons are gained? That is equal to the bonding. So here B is gaining the electrons. So what is the valency of B? It is M. So the A and B are the elements. For two elements only we can form the formula with the criss-cross principle. The two elements are having the opposite property. A is having losing property and the B is having gaining property. A lose the electrons, the number of electrons is called N, the valency is N, and B valency is M. So to write the formula with A and B, how I am writing now you see. So it is A and B. So A is losing the electrons. The electrons is called valency. It is N. That valency I am multiplying with B. The A valency I am multiplying with B. At the same time, the B valency M I am multiplying with M. So I am multiplying with A. So what happened here? The A valency is multiplied with B. The B valency is multiplied with A. So here what happened here? We are crossing the valencies. We are crossing the valencies in between the two atoms. So A valency is multiplied with B. The B valency multiplied with A. So here we are getting one formula. It is AMBN. What is the formula? It is AMBN. So this formula is called the compound. So with the criss-cross principle, so you have two elements A and B. M and N are the valencies of A and B. So here A valence is multiplied with B. The B valence is multiplied with A. So you are getting one compound that AMBN. So one example we discuss. For example, A equal to aluminium. So here A equal to aluminium. So same time the B equal to oxygen. So here A aluminium, B is oxygen. They are the opposite property elements. The A is having the losing property and B is having the gaining property. So A and B are the opposite elements. Aluminium and oxygen are the opposite elements. So here aluminium is losing electrons. That electrons is called valency. That valency indicating with N. So now only we discuss the aluminium. How many electrons it is lose? 3. So what is the valency of aluminium? It is 3. Same similarly, oxygen is gaining property. How many electrons are gained by the oxygen? It is 2. So oxygen valence is 2. Now I am playing in AMBN. So I am crossing the valencies in between the atoms. So here aluminium and oxygen I am writing the compound. Aluminium valence is multiplied with oxygen. Oxygen valence is multiplied with aluminium. So what you are getting? Al2O3. It is the formula for aluminum oxide. So here we are getting one criss-cross principle. The criss-cross principle is AMBN. In this A and B are the elements. They are having the opposite property. A is losing the electrons, B is gaining the electrons. The gain electrons and losing electrons are crossed. A valence is multiplied with B. The B valence is multiplied with A. So what you are formula getting? AMBN. So here I am taking one example. A and B. A is aluminium. The B is oxygen. Here the number of electrons are lost by aluminium is 3. So the valence is 3. Number of electrons are gained by the oxygen, that is valence is M, that equal to 2. So I am crossed the valency. So what the formula you are getting? Al2O3. That is called criss-cross principle. We can write the formulas for the compound. For 2 element compounds you can write the formula. But some compounds we have more than 2 elements are involved. More than 2 elements are involved. With criss-cross principle, you are not able to write. For example, I have one more compound, that is calcium carbonate, CaCO3. In calcium carbonate, we have 3 elements, the calcium, carbon and oxygen. With criss-cross principle, you cannot find the formula. You are not able to write the formula. So how we write the formula for that compounds? So we need the expansion of criss-cross principle. What is the expansion of criss-cross principle? How you can write more than 2 elements? Now we discuss in part 2. So don't forget to bell. So please do subscribe, like, share, comment and subscribe. Don't forget to bell. Okay? Thank you.